Okay, so in question 1 of assignment 1, we're basically asked to prove two things. In part A, we want to prove the distributive law of the intersection over the union, and in part B, we want to prove the distributive law of the union over the intersection. So we'll start with part A. We want to show that the set on the left-hand side would be a subset on the right-hand side, and vice versa, and that would prove the equality sign. So we first let X be an element of the subset, X be an element of the set on the left hand side. That implies that X is an element of A and one of B or C, right? X is an element of A and X is an element of B union C, which implies that X is an element of A and one of X is an element of B or X is an element of C. So in case 1, X would be an element of A and B, or X would be an element of A and C. So we get these two statements here. Putting that in one line, we get X is an element of A intersect B, or represented by the union sign, X is an element of A intersect C. Thus, we have shown that the set on the left-hand side is a subset of the set on the right-hand side. Now, we have to do it for the right-hand side as well. So we let X be an element of the set on the right-hand side. This implies that X would be an element of A intersect B, or X is an element of A intersect C. This implies that in case 1, X is an element of A and X is an element of B, or in case 2, X is an element of A and X is an element of C. And we can see that from both case 1 and case 2, either case, X is always there. X is always an element of A. And X can be an element of B in case 1, or X can be an element in set C, right? So in both cases, case 1 or case 2, X is always an element of A. And in case 1, X would be an element of B in addition to being an element of A. Or in case 2, X would be an element of C in addition to being an element of set A, right? So we can write that out in terms of set notation like this. And X is an element of A, and which is represented by the intersect, the set of B union C. Thus, we have shown that the set on the right-hand side is a subset of the set on the left-hand side. Thus, part A is proven. Moving on to part B. Okay, so in part B, I'm going to use De Morgan's law to prove the statement. So we let X be an element on the left-hand side. And taking out the set, we apply De Morgan's law. We would get A complement intersect B complement union C complement. And applying the distributive law from part A, we get A complement intersect B complement union A complement intersect C complement. Applying De Morgan's law again, we get A union B intersect A union C. Therefore, A union B intersect C is a subset of A union B intersect A union C. Now we just have to do the same thing on the right hand side. We let X be an element of the set on the right hand side. Take the set out. Okay, applying De Morgan's law again, we get A intersect U, A complement intersect B complement union A complement intersect C complement. And once again, we use the distributive law from part A. We would get right. So this statement here gives the previous statement. If you apply the distributive law of the intersection over the union and apply De Morgan's law again, we get A union B intersect C. Just to check, yep. So we have shown that set on the right hand side, sorry, is a subset of the set on the left hand side.